What is volcano? How are volcanoes formed? How does a volcano erupt and what benefits does it have for nature? Volcanic activity is a fascinating, frightening, and absolutely necessary feature of our planet. Volcanoes are scattered everywhere, from a desert in Africa to the cold climates of Antarctica, islands in the Pacific, and entire continents. Every day, somewhere a volcano erupts. Most of us are familiar with the names of volcanoes, such as the extremely active Mount Agung in Bali, Brarbunga in Iceland, Kilauea in Hawaii, and Colima in Mexico. However, there are volcanoes spread across celestial bodies throughout the solar system. Take, for example, Jupiter's moon Io. It is highly volcanic and spews sulfurous lava from beneath its surface. A small model of Earth, this moon has intense volcanic activity that brings material from the interior to the surface and beyond, and this activity is thought to have pushed out Io for millions of years. Even further away, Saturn's moon Enceladus also has so-called geysers associated with volcanism. Instead of erupting with molten rock, as on Earth and Io, watery ice crystals squirt out. Planetary scientists suspect much more of this ice volcano activity, also known as cryovolcanism, that has spread to distant parts of the solar system. Much closer to Earth, Venus is known to be volcanically active, and Mars has solid evidence of past volcanic activity. Even Mercury shows traces of volcanic eruptions very early in its history. Volcanoes are an important part of building the Earth. Volcanoes play a major role in forming continents and islands, shaping deep ocean mountains and craters. They also reveal landforms on Earth by spewing lava and other materials. Earth began life as a volcanic environment covered with a molten ocean. Not all volcanoes that have been going on since the beginning of time are currently active. Some are already dead and will never be active again. Others are dormant, i.e., they may explode again in the future. This is especially true on Mars, where several volcanoes are among the evidence of their active past. Fundamentals of volcanic eruption. Most people are familiar with volcanic eruptions like the eruption of Mount St. Helens in Washington state in 1980. It was a dramatic eruption that blew away part of the mountain and rained billions of tons of ash on the surrounding states. However, he was not the only one in the area. The Hood and Rainier Mountains are considered active, though not as much as their sister calderas. These mountains are known as back-arc volcanoes, and their activity is caused by plate movements deep within the ground. The Hawaiian island chain originates from a hotspot, a weak spot in the Earth's crust under the Pacific Ocean. The islands formed over millions of years as the crust moved over the hotspot and lava rose to the seafloor. Eventually, the surface of each island reached the surface of the water and continued to grow. The most active Hawaiian volcanoes are on the Big Island. One of the volcanoes here, Kilauea, continues to spew thick lava flows that resurface much of the island's southern region. Recent explosions from a chimney on the side of this mountain have destroyed villages and homes on the Big Island. Volcanoes also erupt in the Pacific Ocean basin, from southern Japan to New Zealand. The most volcanic areas in the basin lie along the plate boundaries, and this entire region is called the Ring of Fire. In Europe, Mount Etna in Sicily is quite active, as is Vesuvius, the volcano that buried Pompeii and Herculaneum in 79 AD. These mountains continue to affect the surrounding areas with earthquakes and occasional flows. Not every volcano creates a mountain. Some volcanic vents send out layers of lava, particularly from undersea eruptions. Volcano vents are active on the planet Venus, where they cover the surface with thick, fluid-resistant, slow-flowing honey-like lava. Volcanoes erupt in many different ways on Earth. How do volcanoes explode? Volcanic eruptions provide pathways for materials below the Earth's surface to rise to the surface. They also allow the Earth to dissipate its heat. Active volcanoes on Earth, Io and Venus, are fed by underground molten rock. On Earth, lava emerges from the mantle, the layer below the surface. When there is enough of molten rock called magma and the pressure on them is sufficient, a volcanic eruption occurs. In many volcanoes, magma rises from a central tube or throat and emerges from the top of the mountain. Elsewhere, lava, gases, and ash flow out of the holes. They can eventually form cone-shaped hills and mountains. This is the style of eruption that most recently occurred on the Big Island of Hawaii. Volcanic activity can be fairly quiet or quite explosive. When there is a very active flow, gas clouds can rise from the volcanic caldera. These are quite deadly because they are hot and move fast. Volcanoes as part of planetary geology. Volcanoes are often, but not always, closely associated with continental plate movements. Deep within our planet's surface, giant tectonic plates are slowly moving and slamming against each other. At the boundaries between plates where two or more of them come together, magma is dragged towards the surface. Pacific Rim volcanoes formed through a process in which plates slide together, creating friction and heat, allowing lava to flow freely. Deep-sea volcanoes also erupt with magma and gases. We don't always see eruptions, but pumice clouds, rock from the eruption, eventually rise to the surface, forming long rivers of rock at the surface. As mentioned earlier, the Hawaiian Islands are actually the result of what's called a volcanic smoke cloud under the Pacific Plate. The Pacific Plate is slowly moving southeast, and as it moves, clouds of smoke heat the crust, sending material to the surface. As the plate moves south, new spots warm up and a new island is formed as molten lava rises to the surface. The Big Island is the youngest of the islands to rise above the surface of the Pacific Ocean, but newer ones are still forming as the plate shifts. One is named Loihi and is still underwater. In addition to active volcanoes, various parts of the Earth contain structures called supervolcanoes. These are geologically active regions located above huge hotspots. The best known is the Yellowstone caldera in northwest Wyoming, USA. It has a deep lava lake and has erupted several times over geological time. A scientific look at volcanic eruptions. Most people are familiar with the curved-looking, sticky pahoehoe lava, pronounced pahoehoe. It has the consistency of melted peanut butter. The formation of thick layers of black rock comes from cooling too quickly. The other type of lava that flows from volcanoes is called AA, pronounced aha. It looks like a moving lump of coal. Both types of lava release the gases they carry as they flow. Their temperature may exceed 1,200 degrees Celsius. Hot gases released in volcanic eruptions include carbon dioxide, sulfur dioxide, nitrogen, argon, methane and carbon monoxide, and water vapor. Ash, which can be as small as dust particles and as large as rocks and pebbles, is formed from cooled rocks and is ejected from the volcano. These gases can be quite deadly in small quantities, even on a relatively quiet mountain. In highly explosive volcanic eruptions, ash and gases mix together in a way called pyroclastic flow. Such a mixture acts very quickly and can be quite deadly. Washington's St. Helens, the eruption of Mount Pinatubo in the Philippines, and the eruptions near Pompeii in ancient Rome, most people died from such lethal streams of gas and ash passing over them. Others were buried in the ash or mud floods that followed the eruption. Volcanoes are necessary for the evolution of planets. Volcanoes and volcanic flows have affected our planet and others. Since the beginning of the solar system, they enriched the atmosphere and soil, radically altered, and at times threatened life. They are part of life on an active planet, and they have important lessons to teach on other worlds where volcanic activity takes place. Geologists study volcanic eruptions and related activities and work to classify all types of volcanic land features. What are the ways to classify volcanoes? There is no easy answer to this question, as scientists classify volcanoes in several different ways, including size, shape, explosiveness, lava type, and tectonic formation. Moreover, these different classifications are often interrelated. For example, a volcano with very powerful eruptions is unlikely to form a stratovolcano. Stratovolcanoes, it is a high, conical-shaped volcano composed of many layers of hardened lava, tuff, and ash. Let's take a look at the 5 most common ways to classify volcanoes. Active, silent, or dead? One of the simplest ways to classify volcanoes is by their recent eruption histories and future eruption potentials. For this, scientists use the terms active, quiet, and dead. In general, an active volcano is one that has erupted in recorded history. This varies from region to region or is showing signs of eruption, gas emissions, or unusual seismic activity in the near future. A dormant volcano is not active but is expected to erupt again. Determining whether a volcano is active, silent, or dead is not easy, and volcanologists can't always get it right. After all, it's a human way to classify nature that way, and nature is unpredictable. For example, Four Peaks Mountain in Alaska was dormant for more than 10,000 years before it erupted in 2006. Geodynamic properties. About 90% of volcanoes occur at convergent and divergent, but irreversible, plate boundaries. At convergent boundaries, one crustal layer sinks under the other in a process known as subduction. When this occurs at ocean-continental plate boundaries, the denser oceanic plate sinks below the continental plate, bringing with it surface water and hydrated minerals. The submerged oceanic plate encounters increasingly higher temperatures and pressures as it descends, and the water it carries lowers the melting temperature of the surrounding mantle. This causes the mantle to melt late and form floating magma chambers that slowly rise into the crust above them. At ocean-ocean plate boundaries, this process produces volcanic island arcs. Differential boundaries arise when tectonic plates diverge. When this happens underwater, it is known as seafloor spreading. As the plates separate and form cracks, the molten material in the mantle is released and rises rapidly upward to fill the void. When it reaches the surface, magma quickly cools and forms new soils. Thus, older rocks are found further away, while younger rocks are found at and near divergent plate boundaries. The discovery of the different boundaries and the dating of the surrounding rocks played a large role in the development of theories of continental drift and plate tectonics. Hotspot volcanoes are a completely different formation. They usually occur on the plate rather than at plate boundaries. The mechanism by which this occurs is not fully understood. The original concept, developed by renowned geologist John Tuzo Wilson in 1963, assumed that hotspots were caused by plate movements over a deeper, hotter part of the Earth. It was later theorized that these warmer, subcrust segments were mantle capillaries, which are deep, narrow streams of molten rock rising from the core and mantle due to convection. However, this theory is still the source of contentious debate within the earth science community. Volcano types. Cinder cones are small, steep, conical piles of volcanic ash and rock that form around explosive volcanic vents. It usually occurs on the outer edges of shield volcanoes or stratovolcanoes. The material containing the ash balls is usually mud and ash, so light and loose that it cannot accumulate in magma. Lava can seep from the sides and bottom. Shield volcanoes are large, often miles wide, and have a gentle slope. They are the result of liquid basaltic lava flows and are often associated with hotspot volcanoes. Stratovolcanoes, also known as composite volcanoes, are the result of many layers of lava and pyroclastic. Stratovolcanic eruptions are normally more explosive than shield eruptions, and their high-viscosity lava has less time to travel before it cools, resulting in steeper slopes. Stratovolcanoes can reach heights of 20,000 feet. Explosion types. The two predominant types of volcanic eruptions, the explosive and flood type, determine which types of volcanoes form. In flood-type eruptions, less viscous, fluid, magma rises to the surface, allowing potentially explosive gases to escape easily. Flowing lava flows easily downhill, forming shield volcanoes. Explosive volcanoes occur when, with less viscous magma, dissolved gases still reach the surface without leaking. Then, pressure builds up until eruptions send lava and pyroclastics into the troposphere. Volcanic eruptions have also been described using the qualitative terms Strombolian, Vulcanian, Vesuvian, Plinian, and Hawaiian. These terms refer to specific explosions and plumes of smoke, the material ejected, and the size associated with them. Volcanic Eruption Index, VEI. Developed in 1982, the Volcanic Eruption Index is a scale of 0 to 8 used to describe the size and magnitude of an eruption. In its simplest form, the VEI is based on the total volume discarded, with each successive interval representing a tenfold increase from the previous one. For example, a VEI for volcanic eruption spews out at least 0.1 cubic kilometers of material, while a VEI 5 ejects at least 1 cubic kilometer. However, the index, it also takes into account other factors such as plume height, duration, frequency, and qualitative explanations. Thanks for watching the video. Subscribe my channel, support me. Goodbye.